Okay, dma070, and dma070, we will be working with rational expressions, rational functions, anything that has to do with something rational. So when you see the word rational expression, I want you to think about a fraction. What we're going to do is we're going to have items to work with where the expression looks like a fraction, and then what's going to happen is in the numerator or in the denominator, we're going to have an expression. So for example, if I were to have this trinomial over this binomial, this would be called a rational expression. Find the value of each expression for the given values of the variable. If I were to say if x is an 8, if x equals 8, what is the solution? And what I hopefully think you might notice is I can plug in an 8 here and here, but think about fractions. What's the one thing we cannot have with a fraction? The denominator cannot be equal to a 0, can it? If the denominator is equal to 0, it would be what we call undefined. And if I give you an 8 to plug in, the first thing you're going to do is look at the denominator. And if I plugged in an 8, 8 minus 8 would give me a 0, which would make this whole expression undefined. The first part of section 1 is talking about two things. What makes a rational expression undefined? And so we're looking at what makes a rational expression undefined, and then we'll look at just simplifying expressions. So what makes a rational expression undefined means when is it equal to 0? All you have to do is factor the denominator only, factor the denominator only. We do not have to worry about the numerator. The numerator can be 0 all day long and it's fine because the answer will be 0. But we can never have 0 in the denominator. After you factor the denominator only, determine what values make it equal to 0. In other words, think back to dma070 section 13. That was when you had an expression that you had to factor. It was set equal to 0, and then you gave solutions of what made each denominator equal to 0. So let me give you an example here. Let's say we have 3 over x minus 7. What value would make this undefined? If I took x minus 7 and set it equal to 0, I would move the 7 over and x would be a 7. So this value 7 is what would make that undefined. An answer could be all real numbers except when x is a 7. If you had something such as y plus 5 over 9, what would make this undefined? Well, the denominator does not have a variable, so no numbers make this undefined. Any answer is acceptable for this. There is nothing to make it undefined. let's say I give you this one. Let's say we have t over 2t squared minus t minus 1. So if I'm going to factor this, I'm only looking at the denominator. I'm going to factor it to two terms. They start with t. Since it's 2 times negative 1, we need to remember to divide by that 2. And then let's go back and review those calculator steps. Remember, on y1, we would do 2 times negative 1. So we're going to have negative 2 divided by x. And then on the second row, bars, arrow, enter, enter, plus x. Enter, plus x. Okay. And then we're going to do second table, and we're going to look for our middle term in the third column, which was a negative 1. So we're going to use a minus 2 and a plus 1. So we're going to use a minus 2 and a plus 1. Then we want to reduce these. The first one, 2 over 2, is just a 1. And then this, now, since we're determining what makes it undefined, we're not going to do bottoms up. We're going to leave it just like it is, because what we want to do is what would make each one equal to 0. So my answer is going to be all real numbers except, and what would make it equal to 0? Here, what would make it a 0 would be a positive 1. Here, what would make it be equal to 0 would be the opposite sign, which is a negative 1/2. So a solution would be everything except what makes the denominator be and set equal to 0. That's the first part of section 1, is simply what makes a rational expression undefined is what makes the denominator equal to 0. We're still in the first section. In the first section, we are going to also look at simplifying an expression. So simplify a rational expression. I'm going to make the rules real simple on this. When you simplify, rational, I lose things sometimes. What you're going to do is to factor each term, and then you're going to cancel out whatever might be in a numerator, cancel out numerator, denominator that is the same. So in other words, factor and cancel stuff out. The rules are really that simple. Factor each term and cancel out the numerator, denominator that is the same. So let me give you a sample of that. And I'm over on page 7-9, and I'm going to do some of these examples that you have here in your workbook. So we have an x minus 5 over x squared minus 25. And if you have your workbook, feel free to take it out and be putting these answers in your workbook. The numerator, as you can see, I would say, okay, that's already factored. I'm just going to put a parenthesis around it. This I can factor. It's the difference of squares. The middle term is that 0x. So if I'm using my calculator, just to review the steps, I would do negative 25 divided by x. Keep that y1 plus x, second table. Look in the third column for the 0. Positive 5 and negative 5. So that's going to be an x plus 5 and an x minus 5. So what I've done is this denominator I factored. This was already factored. When I look at this, what can I cancel out? This x minus 5 and this x minus 5 are the same. When they cancel, technically it becomes like a 1. When you give your answer, this is a common mistake. Somebody's going to put x plus 5 and they're going to walk away from the problem. Can't do that. This x plus 5 is located beneath the line of the fraction, so it's in the denominator. what we need to do here, since that canceled, we're going to still need to use that 1 as a placeholder. So we're still going to leave that there, okay? Let's do another one. And I'm still using what you've got here in your workbook on 7-9. Here we've got a 5y minus 15 and a 3y minus 9, okay? In this numerator, I can factor out a 5. When I factor out a 5, I'm left with y minus 3. In this denominator, I can factor out a 3, and that leaves me with a y minus 3. Now, when I look at this, what I have in common that can cancel is that y minus 3. So all I have left is 5 times 1 and 3 times 1. So I've got 5 thirds. And I'm done. So I'm factoring. Now, sometimes when you factor, it's just a greatest common factor. Sometimes you have to factor and you end up with 2 parentheses. So even though it may appear as though you don't have a lot of problems on some of these, it's because you are going to have a lot of factoring steps within each of the problems that you're doing. Okay, so for this one, we're going to factor the numerator to 2 terms, and we're going to factor this denominator into 2 terms. Okay, so for the first one, it's an understood 1. So 1 times negative 9. Let's go to our calculator. Clear. We're going to do negative 9 divided by x, second table, and our middle term was a positive 8. So for the positive 8, we're going to have a positive 9 and a negative 1. So a positive 9 and a minus 1. It doesn't matter which is first or second. The important part is that the sign is correct. For the denominator, 1 times 4, and then we're looking for a negative 5. So here, we're going to clear and do 4 divided by x. Now notice, I thought I hit clear, but it didn't clear out. This will give me a wrong answer because it's reading it as an x squared. You see how it does all this weird stuff? So I was trying to hit clear. I always make sure everything clears out. And let me type that again. 4 divided by x. Okay. And then second table. And we're looking for a negative 5. Okay, here's my negative 5. So I've got a negative 1 and a negative 4. So a x minus 1 and a x minus 4. Now I can see what cancels. This x minus 1 can cancel out. And my final answer is going to be x plus 9 over x minus 4. Now, something that people accidentally do is they look at this and they go, ooh, let's cancel out these x's. You can't do that. This is a binomial. If it would help you to not accidentally make that mistake, keep the parentheses around it. The computer is fine if you still type it. It won't do anything. It won't mark it as wrong. You can leave it there. But that would be your final answer. Okay, here we have 6x squared minus 24, 3x plus 6. Okay, in the first one, I can factor out a greatest common factor of 6. That leaves me with x squared minus 4. In the bottom, I can factor out a 3, and that leaves me with an x plus 2. Can this difference of squares be factored? Yes. So I've got an x plus 2, and I've got an x minus 2 over 3, and then the x plus 2. I'm going to cancel out the x plus 2, and 3 goes into 3 once, it goes into 6 twice. So I'm left in the numerator with a 2 and an x minus 2. Everything in the denominator canceled out. So that would be my final solution. Okay, now let me show you something that could potentially trip somebody up, but I want to be sure you're aware of this. In this same particular example, you're going to see on your test. Okay? It's not a hard question. We have x minus 3 over 3 minus x. Now, in the numerator, that's fine. It's in order, descending order. But what I want you to notice in the denominator, the order is wrong. So I'm going to write order. So this would be negative x plus 3. That would be the correct order. So you check the order, that's the correct one. We don't ever start with a negative. So we are going to factor out a negative 1. So if I factor out a negative 1, I'm going to have an x, but look at what I'm going to do. Negative times positive is negative. Negative times what gives me a positive? Negative. Okay, so now my numerator, x minus 3, is just there. Then I'm going to put this beneath, negative 1, and then x minus 3. So I'm just going to move that there. I can cancel something out. This x minus 3 is going to cancel. So I have 1 over negative 1, which reduces to simply just a negative 1. There will be one of these that you will see when you do your test. And you'll have to rearrange the order, factor out the negative at the front, and then you just simplify from there. If you flip over to page 7-12, we'll do one of those there as well, because they have a denominator that's not in the right order. Actually, I'll do number 13. 13, we have 12 minus 3x over x squared minus x minus 12. So in the numerator, that would be a negative 3x plus 12. And I can go ahead and we factor this. This denominator, let's do the calculator. Clear. We've got negative 12 divided by x, second table. We're looking for, our middle number is a negative 1. So negative 1 would be a negative 4 and a positive 3. A minus 4 and a positive 3. Here, I've got to factor out a negative 3. I'm going to have an x and a 4. Negative and positive is negative. Negative times negative gives me a positive. And then I'm going to write down what I factored the denominator to be. So we put things in the right order, factor out a GCF, factor to a trinomial if we can, and then now that's in common, so that cancels out, and I end up with negative 3 over x plus 3. Now, again, that 3 doesn't cancel out. That's all by itself. This is part of a unit. So your final answer is the negative 3 over the x plus 3. Okay, so that's section 1. Now, let me go ahead and give you a big heads up. Section 2 is no harder than that. It's just longer to do. When you're in section 2 is multiplying and dividing rational expressions. So when we multiply and divide them, we're still going to do the same process. We're going to factor and then simplify. Now, the first one or two I'm going to show you, and this is on page 7-15. We have 7a squared b. When we do this, you're going to feel like you're taking dma60 again, because we're going to be reviewing those skills, because you're not going to get away from what you did in dma60. But this is a review of that first section. Now, the way the workbook shows, they factor everything to prime numbers and then cancel out. That's a lot of busy work. I don't do mine that way. What I like to do when I do this one, it's all multiplication. So I'm going to multiply these two numbers, okay? So we're just going to do 7 times 21, 147. So we got 147. I've got an A and I got a B. When we have the same base, what do we do with the exponents? We add them. 2 plus 2 is 4. For the B, we have a 1 and a 2. That gives us 3. On the bottom, we're going to multiply 3 times 14. That gives us 42. Now with our A and our B, this A is a 1, this A is a 1. 1 plus 1 is 2. Here we've got a 2 and a 1. 2 plus 1 gives me 3. So right now, aren't you feeling like you're doing a DMA60 review, section 1? Like base, add the exponents. Now, the 147 over 42, 147 divided by 42, you get a decimal. Math, enter, enter. 7 over 2, 7 halves. So 7's on top, 2 is on the bottom. Now for the A's, when it is the division part, you subtract the exponents. So 4 minus 2 is 2. B cubed and B cubed, that cancels out because they're identical. And you're finished. That's all you can do to this problem. That's a simple multiplication. I don't do these to all prime numbers. I like to multiply my numerals, use the calculator, but do follow your DMA60 rules of exponents. Okay? Okay, let's go to the next one. Let's take 3m squared plus over 6 times 9 over 2m plus 8. Now let me show you how I would write this out. If I were doing this on paper, and I'd have mine in the same color, but I'm going to change colors just so you know what I'm doing here. What I would do is when I look here, I see there's a common factor with the 3 and the m. Both of these have a 3 and a m. 3m from this leaves me with an m. 3 from 12 is 4, and the m cancels. So I factored this, I wrote it directly above, and I'm just going to draw a single line through it. These are just whole numbers. In this denominator, I can factor out a 2, and I'm left with an m plus 4. I'm just going to draw a single line through it because I factored it beneath. So when I look at this, do you see anything here that can cancel? Yeah. What I see that cancels is the m plus 4. That cancels out. Now I'm going to multiply what I have left. 3 times 9 is 27, and we have the letter m. On the bottom, I have 6 times 2, which gives me 12. So I did 3 times 9, and I did 6 times 2. I still need to simplify. Feel free to use your calculator. 27 divided by 12, math, enter, enter. One more time, 9 over 4. So we have 9 over 4, and I still have the m that's on top. So that would be your final solution. Okay. Let's do one more multiplication, and then we're going to move on to division. Okay, so for here, I have x squared minus 25 over x squared minus 3x minus 10 times x plus 2 over x. So everything needs to be factored. In this numerator, this can be factored into two terms. It's going to be x plus 5, x minus 5. It's the difference of squares. This is already just simply x plus 2. It can't factor any further. This, I'm going to factor into two terms. That's all by itself, so it's going to stay here. So this is going to be a negative 10, clear, negative 10 divided by x, second table, and our middle number is a negative 3. So that gives me a minus 5 and a plus 2. A minus 5 and a plus 2. Now I'm going to look and see what can I cancel. I have a x plus 2 that matches, and x minus 5 that matches. So what I have left is an x plus 5 on top and a single x on bottom. Again, that does not cancel out. Put a parenthesis around this. This is a unit. So this does not cancel with anything above. Okay, and that would be your final solution. So the multiplication problems are factor each numerator and denominator and then cancel things out. When we move to the division, I'm going to start the division by doing an example of just basic fractions. Dividing. And I'm just going to put dividing fractions to start off with. If I were to give you, let's say, 12/15 divided by 20 35ths. Okay. What we would do is the first term is going to stay the same. So the 12/15 is going to stay just like it is. We are going to change the division to multiplication. So that's going to become a times. And then we're going to write the reciprocal, or we're going to flip the one on the right. So this one on the right would become 35/20. Once you have done that, then you can cancel things out. So for this problem, 15 and 35 both are divisible by 5. 5 goes into 15 3 times. 5 goes into 35 7. These two numbers both have 4 as a common factor. 4 goes into 12 3 times. 4 goes into 25 times. What I would do is say, okay, 3 times 7 is 21. 3 times 5 is 15. That can still be reduced. Both of them are divisible by 3. That would give me 7/5. And you're finished. The concept here for the problems of the division is that the first one is the same. You change it to multiplication and flip the right one. When I do a problem like this, if you will, look in your workbook on page 7-17 for the original. I personally am not going to recopy the original. I'm going to do number 5. What's on the left side, I'm going to recopy. 9x squared y cubed over 6z. I'm going to change it to multiplication. The denominator, 2z, I'm going to put on top. X to the 7th, y to the 9th on the bottom. As we did a moment ago, this is just now a multiplication problem. 9 times 2 is 18. I have x squared, y cubed, and a z. In the denominator, I have a 6, x to the 7th, y to the 9th, and a z. Now, do I have anything that cancels? That z is going to cancel. 18 divided by 6 is 3. And then I'm going to subtract. 2 minus 7 is negative 5. 3 minus 9 is negative 6. We don't want to write our answer with negatives. So these two negatives are going to go to the denominator. So that's going to be x to the positive 5th, y to the positive 6th. I'm going to do one last problem. And this is the problem on, again, 717. And it's going to be number 8. Now they wrote the letters A. I'm just going to write X's just to make it consistent. X squared plus 7x plus 12. X squared plus 5x plus 6. Make this multiplication. And then I'm going to flip. So the bottom is coming up to the top. And the top is going down to the bottom. Now I'm going to color code this. What we're going to do is we're going to factor each term, and then we're going to cancel stuff out. So let me do everybody in a different color. So this numerator here, I'm going to factor to 2 terms. I'm going to use my calculator, 1 times 12. So we're going to do clear 12 divided by x. Second table, and our middle number was a 7, positive 7. So that gives me a positive 3 and a positive 4. I recommend after you factor something, check it off so that you know that you did factor it. I'm going to factor this denominator here. We've got a 6 and we're looking for the 5. So we got 6 divided by x. Second table, looking for a positive 5. Positive 2 and a positive 3. Once you factored it, check it off. Let's do this one. 15, and we're looking for a positive 8. So 15 divided by x, we're looking for a positive 8, a 3, and a 5. Check that off. And one more. 4, and we're looking for a 5. And not negative, but positive, so we got a 1 and a 4. And at this point, we're going to cancel stuff out. So we have an x plus 3 here and here. Can't do this one because I'd have to have another matching one in the bottom, and I don't. X plus 4 here and here. And then there is nothing else that we can cancel. So your final answer is going to be an x plus 3 with the x plus 5 over an x plus 2 and an x plus 1. The only thing we've not had thrown in the mix that you will probably have is a leading coefficient. And I did do one of those at the very beginning here. Remember, if there's a leading coefficient, you've got to remember to put it here to simplify if possible. You may have some questions where that might be the case. So that is all of sections 1 and 2, and I'm going to stop on that note.